Alright, number one. So the discrete random variable x has the following probability distribution. Okay, so we're given a bunch of values for x, and each of these x have the following probabilities. Okay, now the mean value of the x is 1 and tells us that f1 equals 0.63. Now for those who don't know, when I use a capital F in this kind of question, this is known as the cumulative distribution function. So in other words, we can say that fx is the same as all probabilities of x less than equal that value. In this case, f1 is literally all the values less than equal than 1. So we're talking about the first three values. In other words, the first three probabilities. So we can straight off the bat say that f1 must equal the sum of these three things. So 0.15 plus a plus b. Okay? And all of that directly equals 0.63. Now, let's keep going, yeah? So in this question, they want us to find the value of a, b, and c. Now, with these type of questions, always look at the three key facts, yeah? Firstly, the sum of all probabilities must always equal 1, yeah? So we're talking about this entire row. Now, if you add up all these five amounts, you got 0.15 plus 0.15, that's 0.30 or 0.3, plus a plus b plus c must equal 1. And then just moving all the numbers to the right, so subtracting 0.3, you're left with a plus b plus c equals, well, 1 take away 0.3 is 0.7. So we're basically just trying to make some simultaneous equations here, yeah? Now, and the second point is the fact that we know that the mean value of x is 1. In other words, the expected value of x. That's what mean means here, yeah? Mean is the expected value. Now, to work out the expected value, you just multiply the x value with the probability and just sum all of these up, yeah? So we're just doing these groups. So for the first case, it would be minus 2 times 0.15, which is minus 0.3, plus, and then minus 1 times a is minus a, so it would be minus a. Next one would be 1 times b is b, 3 times c is 3c, and 4 times 0.15 is 0.60, 0.6. And all of that apparently equals to 1. And just like the probability one, guys, yeah, just make all the a, b, c on the left side and all the numbers and collect terms on the right side, yeah? So we got minus 0.3 plus 0.6 is plus 0.3, and then 1 minus it will give us 0.7. So we're left with minus a plus b plus 3c equals 0.7. So this is equation number 2. Now equation number 3, well, we just did it earlier. It's the one involving f1. So we know all of this equals 0.63. So basically just subtract 0.15. You can have a plus b must equal, well, 63 take away 15 is 0.4a. Now we're almost done. Now to work out a, b, and c, we're going to try and solve these triple simultaneous equations with all three variables. Now there's some tricks here, yeah? And the first trick you should try and spot is the fact that a plus b is 0.48. Now if you look at the mean equation, we have a plus b and a c. So what we could actually do is replace this a plus b with 0.48, and then this equation becomes 0.48 plus c equals 0.7. Done. And this is easy to solve now. So subtract 0.48 across, you'll be left with c equals 0.22. And that's 1 done. So now c is done, we can try to work out a and b. So updating some equations, yeah? So let's go ahead and update what? The mean equation here, yeah? So a plus b plus c equals 0.7. I'm going to minus c across now, yeah? So this means we could be left with a plus b equals 0.7 take away 0.22. This should give us 0.4a. Now I'm going to look at the third equation that we found, which is over here, guys, yeah? And I'm going to subtract 3c across, yeah? So we're left with minus a plus b equals, well, c is 0.22. 3c must be 3 times 0.22, which is 0.66. 0.7 take away 0.66 gives us 0.04. Now, almost done. So all you gotta do now is solve these two pairs simultaneously. And there's a number of ways you can do it, yeah? What I'm gonna do is just literally add them up here, because that's easy. If you add across, the a's cancel out, because a add minus a becomes 0. B plus b is 2b. And adding up these two numbers, you get 0.52. And lastly, to get b, just divide by 2. So then you're given a b of 0.26. All right. Now, finally, to get a, just plug b into any equation you see. And I'm going to just use this equation right here. So just making A the subject, you're gonna have A equals 0.48 minus your B value, which is 0.26, and therefore A should be 0.22. And that's it, guys. That's one done. Okay, question 2. So before I read the question, I'm going to look straight at the parts. So the first important thing is to realize that we need to draw a Venn diagram to illustrate the above information. So what is the information? Now, according to the top, it says that a group of 40 families was asked whether their family had a dog, which is D, a cat, C, or a rabbit, R, as pets. Now, apparently, no family had a dog and a rabbit, so these two will not intersect. 2 families had both a dog and a cat. 12 families had a dog, and so on, yeah? So before I carry on, we know immediately that dog and rabbit don't intersect, so we can say, okay, so it's going to be a triple Venn diagram, so let's call this one D. Another one for cats, C. But since we know no one had a dog and a rabbit, so the next one will be hell, which is rabbit R. We gotta make sure that the D and the R circles do not hit each other. So no families had a dog and a rabbit. 2 families had both a dog and a cat, so both a dog and a cat, so this would be 2 here. 12 families had a dog, so the total between the D should be 12, so 2 plus 10 should give us 12. 14 had a cat, so we know the total is 14, but we should see what the intersection is first. 11 families had a rabbit, so we know the total is 11 here. Okay, so we need to figure out what that one is. 9 families did not have any of these animals as pets, so that's actually the outside. So let's draw the outside. So 9 goes outside. Now, to be extra safe, since we've done some of this, we can check some of these out. So 2, 12, and 9. Now, let's go back to the previous two, because sometimes you need to figure out what they would be. So since 14 families had a cat, we can say that, let's call this one A and B. So these 3 must equal 14. So A plus B plus 2 should equal 14. In other words, A plus B should be 12. The sum of these 2 is 12. And we also know that 11 families had a rabbit. So B plus something should equal, B plus C should equal 11. So B plus C is 11. And now one thing we need to know is that because we've got 3 unknowns and we've only got 2 equations, we need a third equation. So one final step we can say is the fact that we know there is a total of 40. So everything here must sum up to make 40. In other words, we've got 9 plus 10 plus 2, which is 21. So that's 21 plus A plus B plus C should equal 40. And now tidying this up, you should get A plus B plus C. Subtracting 21 is 19. And there we have it, guys. We've got 3 equations to deal with. Now, if you solve this simultaneously, you're going to get all the values. Now, just having a look at this carefully, we can just use the third equation and one of these 2 first equations. So what I would do, I'll pick the first one. A plus B equals 12. I will substitute this into the third equation and replace this A plus B with 12. And then we've got plus C equals 19. And then just rearranging this, you'll find that C, if you subtract 12, is 7. So C is actually 7. Now put that over there. Now you could use the equations again, or you could just look at the information once more. So we know that the total for B plus B and 7, because it's rabbit, must equal 11. So therefore B should subtract to 4, because 11 take away 7 is 4. If you want to, you could carry on using the formulas, but that's fine. And then finally, we know that the total number of families that had cats was 14. So 2 plus 4 plus A should be 14. So you got 6 so far. 14 take away 6 is 8. So that should be 8. And that's it, guys. That's literally part A done. And now just quickly looking at part B. So let me just take this off. It says state, given a reason, a pair of mutually exclusive events from these 3. Mutually exclusive means that two certain intervals do not intersect. So certain parts that don't intersect. Well, we clearly see that dogs and rabbits are mutually exclusive since no families had a dog and a rabbit. So that'll be your answer. So you say no family had a dog and a rabbit. So therefore we say that D and R are mutually exclusive. Yeah, and that's it. That's these two done. All right, part C. So find the probability that the family has exactly two of these kind of animals as pets. Okay, so this can confuse people if it's not very clear. What this is telling us that we need to pick a certain family that actually owns two pets. So for example, you have two families that own a dog and a cat, and four families that own a cat and a rabbit. So altogether, you've got 6 families out of 40. And that's your answer. Now, part D. Showing you're working clearly, determine whether or not the events D and C are independent. Okay, so there's a formula for this one. So when something is independent, that means that the probability that D intersects with C must equal the probability that D can be multiplied by C. So this is the straight up formula. So what we have to do here is work out all of this separately. So what is the probability of D and C? This is the intersection of D and C. Well, looking at the what's it called? The Venn diagram, the intersection between D and C is 2. This part here. So we know immediately that this part is 2 out of 40. Now the probability of D is the whole D circle, which is 12 out of 40. And we multiply against the probability of the C circle. So C we had 10, we have 14 out of 40. Now, you just have to do the maths here, yeah? So just doing the maths quickly, you'll realize that 2 out of 40 does not equal 12 out of 40 times 14 out of 40. If you went ahead and simplified this, and because this is the case, this implies that because they're not equal, D and C are not independent. And that's your conclusion. Okay, so moving on to part E and F. So it says that Sarah's family is in the group and her family has a pet cat. Okay, so this is a known fact here. They have a pet cat. Now, find the probability that Sarah's family also has a pet rabbit. Okay, notice how they told us in the statement that they have a cat. So this is a given that statement. And now they want us to find the probability that Sarah's family has a rabbit. So rabbit, given that we know they have a cat. Now, this isn't so bad. When they tell you a given that information, we know that Sarah's family is in interval of cat, which is the red circle I highlighted. So everything out of these 3 numbers. So for part E, we can say the total is out of 2 plus 8 plus 4, right? 14. So the whole cat. And we want to find the probability that within this circle, it's always like that in the given that question. Within that circle, that Sarah's family also has a rabbit. So in that circle, the only part which is highlighted for rabbit is the 4, which is this bit here. So you just write 4 on the top, and that's your answer. That's literally your final answer. So putting this in a calculator, you're doing it now. You get 4 out of 14, and this simplifies to 2/7, and that's E done. Now F is kind of similar, except now it was a bit trickier. They want us to find the exact value of this probability, where you got D uniting with R, given that you don't want a cat, that no family has a cat. So I'm just going to look at the one that doesn't have a cat, yeah? The one that don't have a cat would be everything outside the cat circle, like 10, 9, and 7. So that is, just like the previous one, on the bottom, yeah? So it's going to be 10 plus 9 plus 7. Now we're looking at the part. Now out of these 3 values, we care about D uniting with R of those 3 values, yeah? So when you got D uniting with R, the only one that has D and R, which is the 10 and the 7. 9 is outside them, so you're going to put 10 and 7 on the top. And this is your final answer. Simple as that. And then putting that in the calculator, you're going to get 17 out of 26. And yep, we are done, guys. That's 2 done. All right, question 3. So we've got a firm here that sells washing machines. Now, apparently, when a customer buys a washing machine from this company, the customer is also invited to buy a guarantee policy to cover breakdowns and repairs for the next 3 years. Now, to summarize this quickly, it tells us that this company believes that the relationship between these 2 things, machines sold M and policy sold P, can be modeled by a straight line. Now, what this is telling us actually, guys, yeah, that looking at the data set below, we can see that all the points appear to be moving at positive correlation. So the manager believes that this can be modeled by some kind of linear straight line, or a bit lower, not like that. Now, furthermore, she says that she collected data each for 10 months. So in other words, 10 different data points. The sky diagram below illustrates these data. Now the data below is also summarized below here. So data summarized by the following statistics. Okay. Now jump into the question. It wants us to show that SMP between these two is 1373.6. Okay, that's quite direct. So it's telling us to use a formula. Now to show that this is equal to this, we need to realize that SMP is just simply the sum of MP minus the sum of, oops, that's not how you do a sum sign, minus the sum of M times the sum of P over the sample size N. Okay, in other words, we're going to use the sum of MP, which is this value, this, the sum of M times the sum of P all over 10 months. Okay, so that's your data set. And when you do that, you're definitely going to get 1373.6. Yep, and that's A done. Now for B, it tells us to find the value of the product moment correlation coefficient. In other words, this is the R value, the correlation value, to see if the data is positive or negative. Now we know that R equals, the usual one would be SXY. In this case, it's between M and P. So it'd be S and P over the square root of SMM and PP. Now you just pop in the values here, yeah? So popping in the values, let me just delete these things. You're going to use SMP, so you're going to use the first value here over, so I guess I could quickly write 1373.6 over the square root of SMM, which is here, times SPP. So what I like about this one is that they've kind of already done all the maths for you guys, yeah? So times 382.9. And then when you do this, and you put this carefully in the calculator, you should get an answer of roughly, let me bring it down a bit, correlation of 0.903. Now, if you look at this carefully, correlation values is always between -1 and +1. So if it's close to 1, it's positively correlated. If it's -1, it's negatively. And it looks to me 0.9 is so close to 1. So this is extremely positively or highly positively correlated. Now C. State, given a reason, whether or not the data are consistent with the manager's belief. Now, reviewing the information, we know that the manager believes that the relationship between the number of washing machines M and the policies P can be modeled by a straight line. So in other words, it's positively correlated. The only time you can model something by a straight line, if there's some sort of positive correlation. If there's no correlations, then you can't model by a straight line. So in this case, the answer is yes, it's consistent. Why? Because the R value is close to 1, so it's highly positive. Okay, now we're going to move on to the next slide, guys. Yeah. All right, next part. So the manager noticed that the total number of washing machines sold, so this is the sum of M, guys, yeah, was K times the total number of policies sold, so total number of policies. So this is sum of P. Oh, I can't do a sum properly. And suggest a model in this form. P equals 1 over Km. K is an integer. Find the value of K. Okay, so this formula, I can't lie, is a bit weird, but really what it really wants us to do is to find the value K by using the total numbers of both. And since we know the values of the total of the sum of M and the sum of P is given here, we just got to substitute these values in and find the value K. So the sum of P is 281 equals, and looking at this formula, 1 over K times the sum of M, which is 1124. And now just rearranging this, so making K the subject, all we do is times K across and divide 281. You're going to get K equals 1124 over 281. And when you put this in the calculator, you should get an answer of 4, exactly 4. So all right, next bit. So now we've got a guy who works for this company again and thought that this model oversimplified the situation. Now he suggests that we use a linear regression of P on M, which may be more appropriate. Now when they say linear regression, what we're used to seeing is a form which takes like this: y equals a plus bx, okay, where we have to find a and b. Now because they're using P on M, we essentially have P equals a plus bm. So just replace y with P and x with m. Now let's look at the question. So find the equation of the linear regression of P on M, giving your answer in that form. Okay, so again, all you need to do find is A and B. Now to calculate these parameters, we always start by finding B first, yeah? and B always equals what we're interested in. So because they want P on M, it's going to be SMP. It's always like that. It's always the X then Y. And we found that earlier from part A, which is this value, over the X value, which is SMM. So remember, it's always SXX. In this case, it's SMM. And then put this in your calculator. So we know the value of SMP. We also got the value of SMM. So dividing these two, and the B value should be approximately 0.22717 ... So what I usually do for this kind of question, guys, never round up your values, yeah? Always keep it to like 5, 6 decimal place. And then when you get the answer, round it to 3 sig figs if it goes for a while. Actually, even tell, they tell us here, round it to 3 significant figures. So now you got B, we can calculate A. And sometimes it's easy to forget A. My advice is always make A the subject, yeah? So rearranging the equation here, you're going to get, so subtracting BM across, you're going to get A equals P minus BM. Now, to find the actual value of A, it's literally going to be the sum of P over N minus the value B, which we obtained, times the sum of M over N. Okay, where N in this case is always 10, yeah? And the sum of P and the sum of M are given here. Now, all we got to do is plug this back in. So basically, our equation should look something like that. So it should be A equals the sum of P, which is 281 over 10 minus your B value, 0.22717. So just use the answer key for that one, yeah? Times the sum of M, so 1124 over 10. And when you do this carefully, so hopefully I did it right so far, your A value should lead up to 2.5653, okay? And now we've got it. Now we found A and B. So now we just put into the form they want. So therefore, we can say that the equation they want, so therefore, P should equal, and remember we had A plus BM here, so be 2.57 plus the B value, 0.227 M. Yep, and that's it. That's 4 marks for that, yeah, so that's done. Now, part F. So use Jiang's model to estimate the number of guaranteed policies sold when 70 washing machines are sold in a month. In other words, using your model, which we just found, replace M with 70. And that's it. That's just like easy equation. So we're going to have P equals 2.57 plus 0.227. Replace M with 70. Put this in your calculator and you should get roughly to 3 significant figures, 18.5. Now, when I looked at the mark scheme, they said you can keep any answers between 18 to 18.6. Yeah, so if your answers are somewhere between there, don't worry, you got it. Yeah, but for your previous answer, it should be like that, 2.57. Yeah, but anyway, guys, let's move on to the final part now. All right, final bit. So usually about 70 washing machines are sold in January. Now this company decides to offer a bonus to staff during that month based on the number of policies sold. Now, if the number of guaranteed policies sold is greater than the number estimated by the model, the bonus will be paid. Now, G, state, given your reasons, whether you would recommend that the staff use the manager's model or Jiang's model. Okay, so it's quite a lot of information here. So what it's trying to say here is that they're telling us on average we get 70 washing machines sold in that month. Yeah, so M, let's just say M is 70. Now, this company, so basically, the main idea behind this is that you've got 2 models to choose. We know that M is 70 and you're going to get some p-value. So let's go ahead and plug 70 to both, yeah? So we've done Jiang's model already in the previous question. When M was 70, we had a p-value of approximately 18.5 policies sold. Now, if you plug in M equals 70 to the first manager's model, you're going to get, and don't forget K here equals 4, yeah? You're going to get 1 over 4 times 70, which will give us approximately 17.5 policies. Now, don't forget, this is the number of the policies that the company is giving out. So for every normal company, you want to reduce the number of policies because it will save you money. So in this case, well, given a reason, I would recommend that we use the manager's model, only because the number of policies is lower and it has a lower estimate. Okay, and that's really it. That's your answer. So the answer would be pick manager's model, reason, because it's a lower estimate due to the number of policies sold, so they save money. And that's it, guys. That's 3 done. All right, question 4, guys. So we got a researcher who's studying the birth weight of babies. Now, a random sample of 98 babies was taken, and their birth weights in WKG are summarized in the table below. So, a quick note here, guys. We know that N, which is the sample size, equals 98. So let's just make a note of that here. Now, look at the table below. We can kind of see that the birth weight, which is the key indicator here, is continuous, meaning there's no gaps between anything, and it's flowing nicely. And we can see between 2.5 to the next column is also continuous. So in other words, everything is covered. And the good thing is they actually calculate the midpoint for us here. So that's sorted for us. And we got a frequency. Now, it says here that we may use the sum of f times x, so frequency times midpoint, which is equaling 311.5. And they also calculate the sum of f times x squared. Okay, we don't need this now. This is useful to calculate the mean and the variance or standard deviation. So on the next part, what was it say? A histogram is drawn to represent these data. The bar representing the birth weight between this group, so 1.5 to 2.5, which lies over here, has a width of 1 and a height of 4 centimeters. What this means that if we actually draw a histogram, for example, let's just draw one here. It says that this group between 1.5, let's say it's 1.5 to 2.5, we can say it looks something like that. We know that the width in terms of raw units is 1 centimeters, but if we look at the actual weight, the classification, we can see that the width is also 1 unit. So it tells us that the width 1 unit actually equals 1 centimeter. And likewise, the height, which we actually don't have, but we have in raw units, is 4 centimeters. So we need to firstly work out what is the height of this histogram. Well, when you got a histogram, and this is an important note, guys, the area of the block is always the frequency. The width is the class width. And the height is known as the frequency density. Okay, and frequency density, by the way, is calculated by working out the frequency and dividing it by the class width. If you guys know this formula down, then you can pretty much solve any problems in histograms or these kind of problems. So what I would do is firstly work out what is the actual frequency density, which matches 4 centimeters. To do it, add an extra row, call it FD, and for each one, put in brackets here the actual class width. So for the first group is 1, and next one would be 0.5, and so on, yeah? So the one we actually need for the question is actually for the fourth group, yeah? And the fourth group is here, which also has a width of 0.5. Now, to work out frequency density, again, frequency over class width, we're going to do frequency, which is 16 divided by 1, which gives us 16. For this group, it's going to be 14 divided by 0.5, which is actually 28. Now, going back to this data, which represents this part, by the way, we can see that the height here, or the frequency density, is 16. So this tells us that 4 centimeters equals a height of 16 units of density. So this means that, well, I don't know, so 1 unit is essentially divided by 16, 0.25 centimeters. So one thing to know, yeah, the frequency density and the class width will not always have the same kind of measurements, yeah? So you have to work them out independently. Now going back to the question, it says to calculate the width and height of that bar. So again, draw another rectangle. So let's just keep it simple, yeah? We know that in this group it's between 3.5 to 4, so it's 0.5 units. We know the frequency density is 28 units. Okay, so now matching it using the things we have. So for the width, we know that 1 unit is 1 centimeter. So it's literally 1 to 1. That means for the width, 0.5 units is also 0.5 centimeters. So let's call this the width, yeah? Now for the height, we know that 1 unit is 0.25 centimeters, but we got 28 units, yeah? So therefore, just let's have a look. So therefore, working out 28 units, just multiply 0.25 by 28. And when you do so, you should get 7 centimeters. And that equals the height of this group. And that's it, guys. This is the first part done. All right, part B now. So here we need to use linear interpolation to estimate the lower quartile of the birth weights of the 98 babies. Okay, so let's recall that firstly we had 98, so n equals 98. The lower quartile of a data set is always 1/4 of the sample size. So it'll be 98 divided by 4, okay? And 98 divided by 4, that is 24.5. So we're looking at 24.5th baby. Now to work out where that lies in this data set, we need to firstly arrange this in order, in cumulative order. So what I do is I will look at the frequency first, yeah? Every time you got interpolation, when you got median, quartiles, or anything, look at frequency and put this in order. So first we know that up to 2.5 kg, there were 16 babies in total. Then we know up to 3 kg, so we're saying between 1.5 to 3, so we're summing this. Therefore, the sum of these two means that there must have been 40 babies at this stage. If we keep doing this, we'll eventually get to 98. But we don't need that. We need the lower quartile. We need the 24.5 baby. Well, if we already covered 40 babies, then we know it must be after this group, but somewhere in this interval. So what we're trying to say here, we're saying that by linear interpolation, always draw this first. We're going to say that this lower quartile, which represents 24.5 baby, we want to find this actual value, so it's actual quartile. So let's call this this weight W, yeah? This is the lower quartile weight. We know that this baby lies between after the 16th baby, but before the end of it, the 40th baby. We know at the 16th baby, the maximum weight was 2.5 kg. So that's what we're saying. We know at the 40th baby, the weight was 3 kg. So ultimately, we know that this weight is going to lie somewhere between 2.5 and 3. So somewhere in this group. But where? So to work it out, actually, we just use this cool method. So interpolation tells us that if we find some kind of ratio, if we subtract these two, so pick any matching parallel pairs, W take away 3 over 24.5 take away 40, it must equal another matching pair. So let's say 3 and that, 40 and that. So 3 take away 2.5 over, what's that, 40 take away 16. So linear interpolation is kind of nice. You just kind of match anything. I could have chosen another pair. I could have said, I don't know, 2.5 take away W over 16 take away 24.5. But that's kind of complicated because that means I got W on both sides, which is kind of long to solve. Now, solving this the standard way, what I would do is evaluate this fraction, multiply that by the denominator, and then add 3 across. You're eventually going to get a W solution, or a lower quartile weight of 2.68. And that's it, guys. This means that the lower quartile is represented by the weight of 2.68 kg. And that's it. That's B done. All right, part C. So it tells us that the researcher estimated median to be a certain way and upper quartile to be that. Use the median and quartiles to describe the skewness of the data. Okay, so to describe skewness, what I always do, I just draw a little box plot. So draw a line like this, and draw a nice little rectangle, put a line in the middle and label these the lower quartile, the median, and the upper quartile. And now put the values in. So previously we got 2.68 for the lower quartile. We're given a median of 3.14 and upper quartile of 3.55. So put that there. And now all you got to do is ask yourself, which side is heavier, the left side difference or the right side? If the left side is heavier, then it's negatively skewed. If the right side is larger, then it's positively skewed. So subtracting the difference between these two, we should get a value of 0.46. So that's the weight of the block. But subtracting these two, 3.14 and 3.55, we should get a difference of 0.41. So clearly we can see that the left side is heavier, so it's negatively skewed. So we just write negatively. Yeah, and that's it. Now for D, it says find an estimate for the mean and a standard deviation of the both weights. Well, the good thing is from the very beginning, they gave us some data, which is these two, yeah? So the sum of fx is that, and the sum of fx squared is this. Well, use the first one for the mean and use the second for the standard deviation or variance. So to calculate the mean, let's call it W boss. This is going to be the sum of fx over the sample size. So remember, n was 98, yeah? Over n. So just putting the values in, so 311.5 over 98. You should get an average mean of 3.18. And likewise, for the standard deviation, let's call it SW. So standard deviation of W is going to be the other one. So the sum of fx squared over n. So just like the mean, but now you're going to minus this against the mean squared. So bracket squared. And because of standard deviation, you're going to have to square root your result. So always square root your final answer. And when you do so I'm not going to put in the values, but the top half is going to be this value here, n is 98, and w bar is 3.18 squared. And then that square rooted will give you roughly 0.789. So remember, always give your answers to 3 significant figures if they don't tell you anything, yeah? So that's D done. Now for E, we just go use the formula. So skewness equals 3 times the difference between mean and median. So let's write it down. So part E. So it'll be 3 times the mean. What was the mean again? 3.18 minus the median, which is here, 3.14, all over standard deviation. So 0.789. And then finally, doing this will give you roughly 0.15. And we only do 2 sig figs because it tells us here, yeah? And that's it. All right, final part of question 4, guys, yeah? Almost done, almost done. Now, the researcher read that the birth weights should be approximately normally distributed. So a normal distribution, guys, by the way, always has some kind of mean and a variance or standard deviation squared, yeah? We'll get to this when we see the actual question. And now he decides to split the class between 3 to 3.5 into the following. So it says that the frequency for 3 to 3.25 is 9, and the frequency from this group is 23. So guys, essentially, like we had from 3 to 3.5, now it's split into 2 parts, up to 3.25 and from 3.25 to 3.5, so kind of halfway through the way. However, originally we had 32 in this group here. Now we got 9 in the first group and 23 in the second group. So state, given a reason, what effect this would have on the estimate of the median, and also without any further calculations, which is a big lie, you should do a calculation to help, what effects this would have on the estimate of the mean. Right, so let's think about it carefully, yeah? Let's go ahead and try and think about how we calculate the median for a second, yeah? So the median is, well, the middle value. We got a sample of 98, so we're looking at halfway through 98. We're looking at the 49th candidate, or 49th baby. So if we split this group here, let's go ahead and do it. So if you consider this way, yeah, you had 24 up to this group, there were 40 babies. Now for some reason it doesn't go up to 72 now. You're adding 9 more, so it goes up to 49. So this means that the 49th baby is actually equivalent to the weight of 3.25 kg. So what actually happened is that the weight increased because previously the median was actually 3.14. So all we say now, okay, the median increased. Now, as for the mean, guys, yeah, by the way, if you're a bit confused, drop me a message and we can talk about it in more detail, yeah. So for the mean, however, what happens now is that, remember how when we calculate the mean, we always multiply across and then add them up, and then we get some sum of total fx, yeah. In this case, you now got 6 groups, so you've got more things to multiply. The thing is, when you've got more things to multiply, typically it increases, yeah. That's the truth. Now, if you're not too sure why, what I would do is just quickly work this out. So finding the midpoint of this group is actually 3.125. Trick, just add these two numbers and half 9 to get this fx. And the second group is 3.375. And you multiply that against 23. And when you multiply them both and you add them up, you get a total of 105.75. Whereas if you did the original group, which was 32, multiply this value, you get a total of 104. So immediately you see it's increased here. So if that increases, if you divide against both of them by 98, this will still be bigger. So therefore the mean also increased. And that's it, guys. This is literally our assumptions. Alright guys, question 5. So before we go ahead and solve this problem, there's 2 things I want to talk about here. Firstly is the fact that we're doing a normal distribution question, meaning we need to refer to the tables, in other words the normal tables. And the second thing is we also need to look at the percentage point tables. Now if you've got a calculator that can calculate normal distribution problems, then you're going to ace this, no problem. But because there are 3 markers, I believe you need to use the tables. I'm not 100% sure, guys, so could someone actually leave me a comment below and just confirm that with me? So that way, future questions I can talk about both. But yeah, so looking at this, we can jump straight in and we'll talk about things as we go along. So, number 5. The random variable x has a normal distribution with a mean 10, okay, and standard deviation 6. Now, A, find the probability that x is less than 7. Well, when you want to solve something like this, you need to always convert to something known as the Z form, yeah? And Z stands for the standard normal distribution. All these results are from the standard normal distribution table. That's why I wrote this over here. Z is normally distributed with mean 0 and standard deviation 1. And the second we need to know is that the questions always need to be solved in the less than form. Conveniently, our question is the less than form. So when we do it like that, we can jump in straight away. Now to convert x to z, it's always going to be the variable 7 minus the mean, which is 10, over the standard deviation, which is 6. Now resolving this quickly, you're going to get probability that z is less than, well, all of this is minus 0.5. Okay, so that's nice and easy. Now all we want to do is figure out how to do this. Well, when you got a negative, so because it's negative, we can't use the normal table. So what we have to do is make it positive to actually use it. Now, if it's negative, just whip it out and write 1 minus probability z is less than plus 0.5. So this is a nice transformation, and I highly recommend you memorize it, guys. Now we can easily solve this. Because it's in the less than form and it checks out, we just scan the table for a z value corresponding to 0.5. Well, we've got it right here. So this is the little z value of 0.5, meaning it's got a probability, accumulated probability of 0.6915. So this is just literally 0.6915. And then you just subtract that. And when you do the quick subtraction, you should get an answer of 1 minus that, 0.309. Okay? And that's it. That's literally A done. Simple as that. Now, for part B, we're going to actually use this table here, and you're going to see why. So it says here to find the value of k such that x, the probability of x is between these two things, and it must equal 0.60. Now, to work out this probability, I recommend you draw a normal distribution graph here, the bell curve. The bell curve looks like something like that. And one thing we know about the bell curve is that it's always symmetrical about its mean. And well, since we know that we're dealing with x, we know that x is normally distributed with mean 10, we can say the mean is 10 right there. And we know we're finding the probability between two values. One where we've got 10 minus k, so 10 minus k, and we also got 10 plus k. So the area of interest is here. Now one thing to know, guys, in this normal bell curve, we know the area underneath the curve is always equal to 1, yeah? It's because it's a probability, so it has to equal 1. And we know that the area in the yellow region corresponds to 0.6. So that means the outside is 0.4. But because it's symmetrical, we can say that both these two are the same, and they equal 0.3 each. And by the way, we know it's symmetrical because you can see that there's a distance of what? K from these two, and also a distance of k from here. So it's actually the same distance. Now, because you know these two are 0.3, and the whole thing is equals 1, these white regions are also the same. And to make 1, they must both be 0.2 each. Now, the reason why we did this is because we want to simplify its probability to solve this problem. And what we can now say is that given the fact that the probability of this kind of like interval range is 0.6, we can just look at something easy like, I don't know, probability x greater than here, which is 0.2. So probability x greater than that part, which is 10 plus k, is equal to 0.2. Why are we doing this? Is because we need to use the percentage point table, and we're trying to find what that k value is. Well, to do it, we need to convert it to the z form as well. So changing this to the z form, so remember, you always use the z form when you want to use tables, yeah? It's going to be 10 plus k minus his mean, which is 10, over standard deviation, which is 6. Again, it equals 0.2. Simplifying this middle part, so you got 10 take away 10 cancels out, so you got probability z is greater than k over 6. So almost done, guys, yeah, almost done. Now looking at this table carefully, it says that the values z in the table are those which a random variable, in other words a standard normal, exceeds with probability p. In other words, when its probability z is bigger than that form, it equals a p value. Well, our p value is 0.2. And this little z, which in other words, this k over 6, corresponds to this quantities here. So here's your p, that means your little z must be 0.8416. So therefore, k over 6 must be 0.8416. And now solving that easily, just multiplying, what is it, 6 across, you're going to get a k value of 5.05. And guys, that's it. That's the end of this question. End of A and B, because you still got part C. But always remember, yeah, that you should always put your answers to 3 significant figures if they don't tell you. Yeah? So A is 0.309 and B is 5.05. So it says that a single observation of little x, or just a random thing, of the random variable x, the big distribution, is to be taken. Now a rectangle is drawn on a centimeter grid with these vertices and they have these coordinates. Okay, so this is kind of a new question. So let's go ahead and draw this, yeah? Okay, we know it's got coordinates 0, 0, so I'm going to put it here. X0, so it moves across the x to some point, or x. Then it goes down to both of them, down to x minus 3 each, yeah? So this is 0, x minus 3, and from x it goes down to x minus 3, or 0 to x minus 3. So this means that this rectangle has a length of x, remember 0 take away x, x take away 0 is x, and has a height of x minus 3. Okay, not bad. So C, find the probability that the area of this rectangle is more than 40. So in other words, the area, which is base times that, so x times x minus 3, which is x squared minus 3x, greater than 40. So before we even think about putting into some kind of like normal distribution form, let's go ahead and think about this, yeah? Well, we've got a quadratic equation, we've got a constant, so what I would do is move everything and make it equal to 0. So off the bat, we can say that the area is now x squared minus 3x less than 40 greater than 0. So we move it to the left. And now all we want to do, I guess, is factorize this. Now you could use your calculator and use the polynomial function. You could use a quadratic formula, or you could just factorize. I'm just going to go ahead and factorize, yeah? So we need two numbers that multiply to make 40. I think it's 8 and 5, yeah? So we put the x's here. We know 8 times 5 is 40, and we know that 8 and 5 also can have a difference of 3. To get minus 3, it needs to be minus 8 plus 5, and this is greater than 0. Now, this tells us that the solutions of x and 5 would be 8 and minus 5. However, because it's an inequality here, we need to see if it's bigger or less than. So we need to see what the inequalities are here. Now, the trick for these kind of questions here is that I use something called the true-false table. So this is useful for pure 1, guys. Yeah? So if you're doing P1 or even P2, this is very useful. So let's put minus 5 for here and plus 8 on this kind of number line, yeah? So the main idea is you always pick a value in the middle, which is between here. So for example, 0. And you plug this into the original equation and see if the answer is bigger than 0. Well, if you plug in 0 here, you're going to get 0 squared minus 3 times 0, which is 0. Take away 4 years, minus 40. And that is not bigger than 0. And because that's not bigger than 0, then this part is false, meaning that the outsides would be true. So for these ones, if the inside is true, then the outsides are false. If this is false, then the outsides are true. Now what this tells us is that the values of x when it's less than minus 5 is true, meaning we have x values that can take less than minus 5, or we have x values that can take more than plus 8. So this is kind of like a little quick trick, so you don't need to draw graphs. Now, going back to the question here, they want us originally to find a probability that the area of the rectangle is more than 40. So officially, even though the question was probability area is more than 40, we've now changed it in terms of x here, which we did over here, and we somehow shown that this is the same as these x values here. So the area is now equivalent to finding the probability that x is less than minus 5, or probability x is greater than 8. Okay, so this is where we are. Now, evaluating this is no problem. This is, again, straight up normal distribution. We can do this because we know what the normal variable is. The mean is 10 and the standard deviation is 6. So let's go ahead and expand them both like step by step here. So changing pen. So converting this straight to the z form. So I'm going to do this one first, guys, yeah? This one first. So this is the probability that z is less than, well, copy minus 5, subtract the mean, which is 10, over standard deviation, which is 6. And this is now equal to z being less than minus 2.5. So just doing a quick maths. And again, from the previous question, we said if you got a negative there, just whip it outside. So it'll be 1 minus z is less than 2.5. And again, according to the table, we always note that phi 0 equals this, meaning we can just pick a value straight from the table. Now we know what the little z is, isn't it? is 2.5. So we just scan for 2.5, and when you scan it, you realize it's over here, meaning the corresponding probability is this one. So we know it's 0.9938. So we're left with what equals 1 minus 0.9938. So we'll get to that in a second. We'll evaluate that later, yeah? Now let's look at property x is greater than 8, yeah? So I'm going to shift the screen a bit. We'll do our space, yep. So let's do it here. Property x, oh yeah. So now we're going to work out property x greater than 8. So what we can do, convert to the z form as well. So property z is bigger than 8 minus the mean over standard deviation. Always like that, yeah? And that's basically, like if you simplify that, you should get minus 2 over 6 minus a third, or minus 0.33. So guys, for these questions, yeah, always convert to 2 decimal places, because that's what the table records. The table only looks at 2dp, yeah? Now, once again, you got negative, so whip it out. So it's going to be 1 minus property z is bigger than minus 0.3 plus 0.32, because you took out the negative. However, you're going to notice now that this table only looks at less than values, yeah? So to flip this to a less than, you got 1 minus itself, because remember, it's looking at all the values bigger than 0.33, meaning the other side will be the remainder 1 minus the rest. So this is now going to equal 1 minus, and then factorizing this out, you got 1 minus again, z less than 0.33. And now conveniently, when you expand the bracket, if you bother to, this is actually identical to just probability z less than 0.33. Okay, so that's all it is. That's a less than, yeah? Now, looking at the table for 0.33, because that's what we want, we go into the less than form, check. Well, 0.33 is over here, meaning its corresponding probability is this one. So 0.6293 equals 0.6293. And that's it, guys. Now we got both probabilities. Since you wanted to find the area that this shape is bigger than 40 and it split into these two, we just have to sum up these final answers to get the complete answer. So we say, okay, the probability A is bigger than 40 equals this result plus this result should give us a final result of approximately, the 3 decimal places, 0.636. And that's it, guys. You know, I hope this question helped. Let me know in the comments if you understood everything or if you want more explanations, because it gets kind of deep. It gets kind of deep. Now, it says that a tennis tournament has 5 rounds. After each round, winners go into the next round and losers are knocked out of the tournament. To enter the tournament, players must pay an entry fee of $10. Okay, let's highlight that. But only the person who wins all 5 rounds receive the prize of $260. Ooh, nice. Serena enters this tennis tournament. The random variable S represents the total number of rounds Serena wins. Now, the probability distribution for S is given in the following table. Important thing to note here, this variable S represents the total number of rounds that she wins, right? So for example, if S is 5, means she's won all 5 rounds, yeah? So if this means the probability of her winning all 5 rounds is K over 6. So it looks to me like everything's going up by 1 at the bottom. Now A, show that K equals 20 over 49. Alright, this is not so bad because we've done a probability distribution question in 1. Now, to show this, first things first, we need to know that the probability of all of this must sum up to make 1. So if we added all this up, should equal 1. Quick way to do this, since they all got K, how about we just factorize K out, yeah? And now summing this up, it'll be 1 plus a half plus a third plus dot 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 plus all the way up to a 6. And all of that should equal to 1. Now, if you evaluate the inside bracket, all of that in the calculator, so 1 plus all of this, should give you, well, literally 49 out of 20. Basically upside down of that. And that should equal 1. And then dividing this across, well, K is going to give you what you need. 20 over 49. So, not so bad so far. Now, for part B, find ES, in other words, the expected value S. So expected value is just literally 0 times K plus 1 times K over 2, all the way across, and you sum them up after you multiplied. So our actual general equation should look like this. So expected value S is 0 times K is 0 plus 1 times that is K over 2 plus 2K over 3 and so on, yeah, up until 5 times that, so 5k over 6. In the exam, make sure you just fill out the rest, because you never know how the examiner could feel that day. And now over here, you can just, once again, factorize k, so just delete this because you don't need that. Factorize k, and you're going to get a half plus 2/3 plus ... plus the last one, 5 over 6. And then put all of this in your calculator, so the rest of the values too. That just turns out to be 71 over 20. Okay. Now, your final result is just simply k times 71 over 20. Well, we know what k is. It's 20 over 49. So just 20 over 49 times 71 over 20. 20s cancel out, you got 71 over 49. Yeah, you could leave it as a decimal, but it has to be 3 sig figs then, yeah? Now lastly, find Serena's expected profit if she enters the tennis tournament. So expected profit. So we're talking about including the chance that she's going to win, yeah? So remember in the beginning, it says to enter the tournament, players must pay an entry fee of $10. So if we're going to write this down, we're going to say that the expected profit, so when we go expected profit, we have to involve probabilities, yeah? It's going to be an initial fee of -10, and this is guaranteed. You're going to lose 10 plus. Now, the profit means that she can only win. There is no other place of earning money. And she can only win $260 if she wins all 5 rounds. So she needs to be at 5. Probability of getting 5. And we know what the probability of getting 5 is. It's k over 6. So it's going to be to win 260 with probability of k over 6. Once again, we know what the value k is. K is 20 over 49. So just to sum this up, it would be -10 plus 260 times, so what I would do here, because this k is on the top, it would be this over 6. So 20 over 49 over 6. Okay, that's 20, right? Yep, that's 20. And then putting all of this in the calculator, your expected profit in dollars should be, well, right here actually, in dollars should be $7.69. And that's it. That's the first 3 done. All right, here we go. Second part of question 6. Now Roger also enters this tournament. Given that Roger is still in the tournament, the probability that he wins the next round is a constant p. So that means the probability of him winning is p. Probability of him losing must be 1 minus p. So think of it that way. P and 1 minus p gives you a whole 1. Now the random variable r represents the total number of rounds that Roger wins. All right, cool. D. Explain why probability that r equals 2 gives you that result. Well, what this is telling us is that he's won twice, p times p, and then he loses. So this literally means that Roger wins 2 rounds, then loses the 3rd round. Now, if you want to understand why it's like that, recall this first paragraph here. So you remember it says that a tennis tournament has 5 rounds. And after each round, winners go into the next round and losers are knocked out of the tournament. So this is the key thing. So every time he wins a round, he goes to the next round. So he won the first round, then he goes to the second round. Then he won the second round, but he lost the 3rd round. If he won that 3rd round, it would be p cubed, which would be r equals 3, and then 1 minus p. It means he lost the 4th. So the way it works, you only add 1 minus p if you know for sure you're going to lose after that round. Okay? Now, for part E, it says find in terms of P the probability distribution for R. Now, I've already gone ahead and drawn the table here. So we know it's up to 5 because there's 5 rounds. We know it starts from 0 because you could lose the first round. And this means how many rounds you actually won before losing. So for the first case, if he lost immediately, it'll be 1 minus P. This means that he won 1 game. So he definitely won 1 game, but that means he already definitely lost afterwards. Otherwise, it would have gone to the next numbers. For 2, it will be p squared, and then 1 minus p. Here he won 3 games, and then stop there. Here he won 4 games, so close, but stop there. But in this case, he won all 5 games, so you just write p to the power 5. You don't write 1 minus p, because after you win 5 games, you've won. You can't lose anymore. And that's it. That's literally this part done. Okay, F. Find the smallest value p such that Roger's expected profit, okay, is at least as great as Serena's. Okay, so mathematically, this is saying that the expected profit of Roger, so let's say RP, yeah, expected profit of Roger's, is at least and greater, so greater and equal, than expected value from Serena's profit. Well, we already know Serena's profit because that was the one we got in dollars in part C. This was about, what was it, $7.69, yeah? So essentially we need to basically work out expected value RP and then somehow deal with this inequality. So to deal with it, let's check it out. So expected value of RP, we know that from Serena is basically the same case. The entry fee was -10, so you come in with $10 plus, and we know that to win the prize of $260 would be 260 times winning all 5 rounds. So in this case, p to the power of 5. Now that's it, that's all we can do. But because we've got an inequality, we can now put it on this side, yeah? So ultimately our expression now is -10 plus 260 p to the power of 5 is greater than equal than $7.69. So now all we need to do is pretty much solve for p. So let's add 10 across and divide by 260. We're going to get p to the power of 5 greater than equal than 17.69 over 260. And then taking the fifth root, so we're going to have the fifth root, p is going to be greater equal than, so fifth root of that, of this part here, and that's going to be roughly 0.58418 ... So now we need to pick a certain value p. It says find the smallest value p where the profit exceeds or exceeds Serena's. I mean, you can probably leave it like that, but just to be safe and to round it to 3 sig figs, I'll say then p has to be definitely greater or equal than 0.58. And remember, it has to be actually bigger than 4 in this case, because you can't round down, even though it's natural. If you round down, then it'll actually be less. So you round up to 5. If it's this amount, if the probability is this amount, then you've definitely exceeded the Serena's profit. And that's it, guys. That's pretty much the end of the question. I mean, I hope all of this helped. If you guys got any questions on this kind of topic, let me know in the comment section. And if you guys got any other papers you want me to have a look at or to try, feel free to message me and I'll get back to you guys. Other than that, see you guys next time and enjoy the rest of the video.